For more than 100 years now, light has been this huge, nagging mystery for physicists. It's so weird, right? On one hand, it behaves just like a wave. But on the other, its energy only shows up in these tiny, distinct packets. So, what is it? Well, today, we're going to dive into a pretty wild new theory that tries to finally answer that.
Yeah, and that leads right to the classic question that just breaks your brain. If a photon has zero mass, what is its energy even made of? It feels totally impossible. How can this nothing travel across the entire universe carrying energy?
Okay, so to really unpack this, we've got to take it step by step. First, we're going to question everything we thought we knew about light. Then, we'll look at space from a totally new perspective. After that, we'll see what happens when space-time ripples. That'll lead us to what light is in this new model, what a photon really is, and finally, a new unified view of everything. This whole idea, by the way, comes from something called the Unified Postmodern Physics Theory, or UPT for short.
All right, let's jump in. First up, space, a new perspective. So the UPT model, it starts by throwing out one of our most fundamental ideas, the idea that space is just this empty black background for all the stuff in the universe. Instead, it suggests something totally different.
Whoa, hang on a second. You're saying space isn't empty? Like, at all? Then what in the world is out there?
Exactly. According to this theory, there are no empty spots. None. Every single point in space is actually part of what's called the vacuum of a superfundamental particle called a phondon. And get this vacuum isn't just nothing. It has a property called mass intensity. So a great way to think about it is, space isn't an empty box. It's more like a continuous fundamental fabric or substance.
And this fabric of space, it's not just sitting there. It has rules, laws that it has to follow. It's always trying to find a perfect, stable balance. To do that, it's constantly expanding and contracting. And because it's all one continuous thing, a change in one tiny spot is going to affect everything around it. These aren't just ideas. In this model, these are the absolute fundamental rules of reality.
Okay, part 2, when space-time ripples. So if space is this active, living medium with its own set of rules, what happens when you poke it? What happens when you disturb it? This is where things get really interesting, because this is how we start to understand what a wave, and eventually light, actually is.
Okay, that makes sense. If it's all connected, then a poke here is going to be felt over there. But how does that turn into a wave that travels? Why doesn't it just, jiggle a bit right there and then stop?
That is the perfect question, and the process is actually super intuitive when you think about it. So imagine you disturb the mass intensity at one spot. Let's call it point A. To get back to its happy, balanced state, the vacuum at A has to either contract or expand. But remember, space is continuous, so when A moves, it forces its neighbor, point B, to adjust, and B's adjustment then forces C to adjust, and so on. It's a perfect domino effect, and that chain reaction, that propagating series of adjustments, that is the wave.
So here's the absolute key takeaway. In this model, a wave isn't a bunch of little particles flying through space, it's space itself that's doing the waving. It's the phondon vacuum doing this continuous, rippling dance of contraction and expansion. The wave isn't a thing, it's a process.
All right, on to part 3, light as a space-time wave. So we've got this idea that a wave is just a ripple in space. The big question now is, what does this have to do with light?
Well, the answer, according to UPT, is actually unbelievably simple. Light isn't some separate thing that travels through the vacuum of space. Light is the vacuum of space waving. It's just a specific kind of these space-time ripples we've been talking about.
And this is where it gets really, really cool. This one idea unifies the entire electromagnetic spectrum. Think about it. Radio waves, microwaves, the light you can see, X-rays, gamma rays, they aren't actually different things at all. They're all the exact same phenomena. They're all space-time rippling. The only thing that makes them different is their frequency, basically how fast the vacuum is doing that contraction-expansion dance.
Okay, so this whole space-time ripple thing explains the wave nature of light perfectly. But now we've got to tackle the elephant in the room. Part 4, what is a photon really? We still have to explain that weird particle side of things.
Exactly, because for all this talk about continuous waves, we know from experiments that when light interacts with matter,
The energy shows up in these little chunks, these quanta we call photons. And we have the equation for it, E equals h nu. So how can a smooth, continuous wave in space deliver a lumpy, discrete packet of energy? And this slide right here gets to the absolute heart of the matter. In standard physics, we think of the photon as a real, fundamental particle, like a tiny bullet of light. But UPT says, no, that's not it at all. The photon isn't a fundamental particle. It's just a label, an effective label, for a specific amount of energy that the wave is carrying.
So UPT gives it this name, the effective photon. And it's so important to get this. It is not a physical object. It's not a thing. It's just the name we give to the smallest chunk of energy that a light wave of a specific frequency can either drop off or pick up when it hits something, like an electron in an atom. So the wave itself is perfectly smooth and continuous, but the way it interacts and exchanges energy happens in these discrete, chunky steps.
And just like that, the whole wave-particle duality thing kind of dissolves. They aren't two different things fighting with each other. They're just two different aspects of the same single phenomenon. The wave part is the real physical process, space-time doing its ripple. And the particle part is just our label for the discrete packet of energy that this rippling process happens to be carrying.
Okay, so let's put all the pieces on the table and look at the final, unified picture that this theory paints for us.
This chart really sums it all up perfectly. So at the very bottom, you've got space, this active, continuous vacuum of photons. Then you have a wave. That's just a ripple, a series of contractions and expansions in that vacuum. Light? That's just a specific type of that wave, defined by its frequency. And finally, the photon. It's not a particle. It's just what we call the discrete energy packet that the light wave carries. See? It's a complete, logical picture, built from the ground up.
So let's go all the way back to that first question we asked. What is light? Well, according to this new theory, the answer is kind of mind-blowing. Light isn't a thing. It's a verb. It's an action. It's the process of space-time itself, rippling, contracting, and expanding to carry energy from one side of the universe to the other. And that leaves you with a pretty big final thought, doesn't it? If light is just space itself in motion, what else is?